black body radiation curve first was explained by the Max Planck. So when the object is heated, it's emitting the light. So it has a different wavelength. When the body is very heated, it is like a red color. When the temperature of the body is increases, it will become a reddish orange or yellowish orange. Then again that body is increases, finally it attains the white color. So when the body in a white color, it emits the all the colors. So that means white color means it's in the maximum temperature. That is 6000 Kelvin. Okay, 6000 Kelvin is the maximum temperature. And see here, that's a 4000 Kelvin, 3000 Kelvin is a very low temperature. In that temperature, that intensity is very low. But when temperature is increases, that intensity of the light is also increases. So this is a black body radiation. So surface of the sun is a 6000 Kelvin and carbon arc lamp is 4000 Kelvin and lamp filament maximum is 3000 Kelvin. So it's a black body radiation. Okay. So only small portion is there. So next one, we are going to see that when the light is allowed to fall on the, when light is allowed to fall on the any prism, so it is deviated, it produces the 7 color, that's called spectrum. Okay, 7 color, from violet to red it appears, it's a spectrum. There is a 2 types of spectra is here. The 2 types of spectra is here. One is the emission spectra, another one is the absorption spectra. So now we are going to see the types of spectra. The types of spectra can be taught in 2 types. One is the emission spectra, another one is the absorption spectra. The emission spectra. Emission spectra is the self-luminous source is taken. The emission spectra, each source has its own cathode emission. The emission spectra can be divided into 3 types. So light is passing through the prism and it gives the 7 colors. That's the emission spectra. So that can be classified into 3 types: continuous spectrum, line spectrum, and band spectrum. So there are 3 types of emission spectra. The emission spectra is classified into 3 types. Next one is the absorption spectrum. Absorption spectrum means when light is allowed to pass through a medium or a absorbing substance, then the spectrum is supplied is known as absorption spectra. Here cool gas is a absorbing substance. See, that is black color light is there. That was absorbed by the cool gas. That's why this black color light is produced there. So this type of spectra is called absorption spectra. Absorption spectra, again it is classified into 3 types. One is continuous absorption spectra, line absorption spectra, and finally band absorption spectra. So in that types of emission spectra, first one is the continuous emission spectra. The continuous emission spectra, it is the light comes from the incandescent light, or in the incandescent light means that incandescence means the solids are emitting the light in a very high temperature. When the solids in a very high temperature, it will emit the light. So that incandescent light, lamp that is producing the white color light, from that white color light is passing through the prism, it will divide into 7 colors. So this is called the continuous emission spectra. Example for that, incandescent solids, liquids, gases, carbon arc. These are all the examples for continuous emission spectra. Next one is line emission spectra. Line emission spectra is that gas emitting in a spectral light. It is that atoms. When the gas is heated up, that atoms are emitting the spectral lights. That's called line spectra. The line spectra has a definite wavelength and frequency. These lines are as the characteristics of element, which means it different elements having the different wavelength. So using that we can find out that element. So you can see the different element, potassium, calcium, magnesium, whatever it is. These element has the specific wavelength. So using that wavelength, we can find out that element also. From the element, we can find out wavelength. In that particular wavelength, we can find out the element. Right? Then last one is the band emission spectrum. The band emission spectrum is not a band. It consists of several number of very closely spaced spectral lines that is overlapped together, forming a specific band. That's why it's called band spectrum. You are seeing that it's look like a band, but it's not a band. It contains large number of lines. It looks so it is like a band spectrum. So the line, the spectrum has a sharp edge, one end, and another end is padded away. So in band spectrum, the band of that one end is very sharp. The other end of the band is padded away. That is, it will the intensity of the light is decreases. Band spectrum is a characteristics of the molecule. You can study the characteristics of the molecule and structure of the molecule can be studied using the band spectra. So example for the band spectra is hydrogen gas, ammonia gas in discharge. So these are all the band emission spectra. The next thing is absorption spectra. So absorption spectra again it has the three types: line absorption spectra, continuous absorption spectra, band absorption spectra. First one, continuous absorption spectra. Continuous absorption spectra means suppose you are wearing a blue color glass, you can able to see all the images in the blue color because the other wavelength of the color is absorbed by the glass. That's why you are able to see only one wavelength, that is blue color. So all the objects are look like in a blue color. So it's called line absorption spectra. Continuous absorption spectra. Next one is the line absorption spectra. You know that sodium vapor lamp emitting the light of 5890 angstrom and 96 angstrom. There are two specific wavelengths. It is in yellow color. Suppose when white light is passing through a sodium vapor lamp and it is examined by a spectrometer, you can able to see the two dark lines. That two dark lines are yellow color light can be absorbed by the sodium vapor lamp. So that type of absorption is called line absorption spectra. Next thing is band absorption spectra. When white light is passing through the iodine vapor, iodine vapor or chlorophyll or the blood, you can see that dark bands are continuous bright background is uptight. This type of band also uptight now white light is passing through the dilute solution of blood, so or chlorophyll. So you can produce the band spectra. So using that band spectra, we can study the molecules and the compounds of inorganic compounds, organic and inorganic compounds. So it's called band absorption spectra. So now you can see the continuous absorption spectra. So continuous absorption spectra. So when white light is passing through the prism, it will give the 7 colors. So this is called dispersion. It happens because light different wavelength or color refract or bends by different amounts inside the prism. So continuous light is emitted from the source. So the wavelength it contains all the colors, violet to red. All the colors are here. So it's called continuous emission spectra. So it is emitted by the incandescent solid, incandescent electric. Then powerful now. These are all the sources of emitting the continuous electric development. Next one is continuous spectra. Last topic, Fraunhofer lines. So Fraunhofer lines, we have a solar spectrum. The light is passing through the prism. It can deviate it, can get the large number of dark lines are appear in a spectrum. The dark lines are called Fraunhofer lines. So when you examine the solar spectrum means light comes from the sun. That can be examined by the spectrometer. You can get the large number of dark lines. That's called the solar spectrum. It's called photosphere. The temperature is 14 million Kelvin. So it is in a very high temperature. It emits the continuous spectrum. So inside the photosphere, inside the sun. But chromosphere, it is comparatively the temperature is 60,000 Kelvin. It's very low temperature. So that compared to low temperature can absorb that continuous spectra. So that what are all the elements are present in the atmosphere of the sun can absorb the wavelength, so you can obtain the large number of dark lights. The dark lights are indicating that what are all the elements are present in the sun atmosphere. So all the elements are in the gaseous state. So that gases are absorbing the continuous emission spectra. So it is after that we can calculate that what are all the elements are present in the sun. So that's called Fraunhofer lines. So the solar spectrum it contains large number of dark lines. The dark lines are called Fraunhofer lines.